Hello students. So today we will discuss about case study of customer segmentation. Okay, this is one case study in which we will study how we can do customer segmentation. So in this, I have prepared one Jupyter file for this. So in this, we will cover introduction, then our problem statement, then we will install and import all the libraries which is needed for us. Okay, and then data acquisition and description. We will get data and we will give description for that data. Then fifth step is we will do pre-processing. In pre-processing we will do identification and handling of missing data. Okay, we will try to identify where is missing data and we will try to handle that missing data. Then identification and handling of redundant data. Okay, sorry. After that, identification and handling of inconsistency data types. Okay, then post profiling report. After that we will do exploratory data analysis. After that, customer segmentation techniques. We will use k-means, and I will also discuss about one old technique, that is RFM. Okay, you will come, I think you already know about k-means, but for RFM you will come to know soon. Okay, then we will provide conclusion. Okay, so now talk about this introduction. Here what we are doing, segmenting customer in the process of dividing up mass customer, okay, into groups with smaller needs and wants. Okay, why we do this customer segmentation, guys? Like, we have very large group of customers. Okay, so it is difficult to or it is also not possible that all customer have same mindset. Okay, so we need to divide them and group them into smaller groups so that we can target them individually as per re- requirement. It is same written here. It can help companies to focus on marketing efforts so that customer satisfaction and overall profit can be achieved with at higher rates. Okay, so this is our goal. So problem statement: at some point it becomes impossible to focus on individual customer, and sometimes the communication between customer become complex. We need a way out to understand our customers in a structured and shared manner. Okay, and what is the scenario? KNEC Grant is the UK based, this is the name of the company. KNEC Grant is a UK based non-store online retail company started in 2009. The company mainly sells unique all equip all occasion gift wear. Okay, many customers of the company are wholesalers. There are many customers which are wholesalers. The company is growing at rapid rate. At the same time, they are unable to catch up the customer expectation and mainly healthy relationship, that is for failing in customer relationship management. Okay, CRM, customer relationship management. In order to tackle this problem, they hired a team of data scientists need to automate solution to identify customer and okay. So now we will install our libraries. That is, first library which we will install is data science. This is the package that is required for panda profiling. Then we will install pandas profiling toolbox for generating static report. Okay, then we will upgrade our libraries. Okay, after that we will import our libraries. We will import pandas.pd. Then we will set some options. Um, import pandas.util.testing as tm. Okay, then we will set options for maximum column width, maximum rows, and chained assignment. Okay, then numpy as np from random seed values. So from random import randint. Okay, for scientific Python from scipy import stats. For date time we import date time, and date time import date time as dt. Okay, for data visualization matplotlib.pyplot.cm percent inline. Okay, so all these seaborn. For data modeling we use sklearn.cluster. Okay, import k-means. This we can also do later while we are doing our machine learning part. Okay, Now we will disable our warnings with the help of import warnings. Warnings dot filter warnings action equal to ignore. Okay, now we will move forward. Data acquisition. Okay, so this is our data total. This much records are there and 8 features are there. Okay, and this is the size of data. Okay, stock code, etc. Okay, everything is there, and this is the link. Okay, so define load data link equal to link, and return pd.read csv and file name. Okay, what we are doing here, we are defining function name and then link equal to link and return pd.read csv. Okay, now data equal to name of the data. So this is the name of the data. Print data shape, it will give the shape of the data, and then data dot head. Okay, now data description. In this section we will get information of data and see some observations. Okay, so describe column length. Okay, so what we are doing here, data dot describe dot columns. Okay, so data dot describe, so length is 3. Okay, and then it is describing the columns. Okay, on average customer had brought around quantity of 10. Okay, so this is around 10 of each product. 25% of customers brought product items with less than equal to unit quantity, while 50% and 75% brought product item with quantity less than 3% and less than 3 and 10. Okay, average price of all the transaction item was 4.64 pounds. This much information we can get. Okay, 25% of product items had price of itna. Okay, while has 2.1 pound and 4.15 pounds, that is. Okay, for 75%. Pre-profiling report. For quick analysis, pandas profiling is very handy. For quick analysis, pandas profiling is very handy. So what we are doing, the step is simple. Profile equal to profile report, data frame, profile equal to footer profile report, then we will give the name of data frame, then profile to file output file, then we will give the name of file, and then print accomplished. From google.colab import files.download, and then we will give the file name. Now according to report, there are total 8 variables, out which 5 are categorical and 3 are numerical. Okay, around 2.9% of data is missing, 3.2% of rows are duplicate. Invoice, stock code, description, invoice date features are highly correlated, have high cardinality. Okay, so it is quite normal, because invoice and stock code, description, so this invoice date also, like if 1,000 customer purchasing for today, then invoice date will come for today only, so high cardinality is not a issue here. Okay, so there is absence of correlation among features with each other, so this part is good. Okay, now we will do data pre-processing, identification and missing data. Okay, null data identification and handling. Before handling null data, what we are doing, guys, null frame, we are defining null frame, pd.data frame index equal to data dot columns dot values. Okay, so we are doing index equal to data dot columns dot values, then null frame we will add null frequency, data dot is null dot sum dot values. Okay, and then percent, data is null dot sum dot values divided by data dot shape. Okay, so it will give the percentage. Okay, now a null frame, we will add missing percentage, np dot round percent comma decimal 4 into 100. Okay, so this is the way np dot round percent comma decimal equal to 4 into 100. So null frequency frame dot transpose, so we will transpose this. Okay, so it will come observations, feature, problem, action, required reason, description, missing information itna, drop records, ratio is very less, won't affect the result. Okay, and then customer id, so this also we can drop. Okay, then we will performing operations. Okay, so now just wait for a second. Performing operations. Okay, now we will print what is the data shape before. Okay, data dot shape, and we will do data dot drop and x is equal to 0, and then in subset we will give the name of columns and in place equal to true. And what is the after shape? After handling null data, now that we have performed the operation, let's verify whether the null data has been eliminated or not. Okay, so same code we will repeat. Null frame equal to pd dot data frame, index equal to data dot columns dot values, null frame null frequency equal to data dot is null dot sum dot values, percent equal to data dot is null dot sum dot values divided by data dot shape. Okay, and now null frame missing percentage equal to np dot round percentage comma decimal equal to 4 into 100. Then we will transpose. We can see that we have eliminated null data successfully. Don't worry guys, I will do coding also. First let me explain you what we are doing, then zero data identification and handling. Okay, so what we are doing here, we are defining but one data name, that is zero frame equal to pd dot data frame index equal to data dot columns dot values. Okay, now zero frame we will check for null frequency. Okay, that is data equal to 0 dot count dot values. Okay, then percent equal to data equal to 0 dot count dot values divided by data dot shape uh, index 0. Okay, zero frame missing percentage np dot round percent comma decimal equal to 4 into 100. And now we are transposing. Okay, so after that we will see that price identified as 71 zeros, drop record, price of product item cannot be 0. Okay, some orders were cancelled, so price is 0. Okay, so we will drop those records. Performing operations. Okay, data equal to data and price of data not equal to 0 after handling 0 data. Now we have performed the operation. Let's verify whether the 0 data has been eliminated or not. Same code we will write again. Pd dot data frame index equal to data dot columns dot, so pd dot data frame index equal to data dot columns dot values. So it will be the index of our zero frame. Null frequency. So by this we can see now those zeros values are removed. Identification and handling of redundant data. Okay, so we will try to identify and handle redundant data. In this session we will identify redundant rows and columns in our data if present. Okay, if there is an redundant row or column, we will handle that. Okay, before we will make a copy of our data and analyze the effect. Before we make a copy of our data and analyze the effect, Later down, all the changes will be introduced in the original data. So identification and handling of redundant records. So data underscore copy is equal to data dot copy. Okay. So before handling duplicate rows, we will see contains redundant records. Data copy dot duplicated dot any duplicated dot any. It's true. Duplicate down data copy dot duplicated dot sum. So it will show sum, and shape data copy dot shape. It is the shape. It turns out that 26,479 duplicate rows present in our data. We will drop these records as they are not useful for our analysis and model development. Now we are performing operations. Before shape is equal to data copy dot shape. Okay. Data copy dot drop duplicates. In place equal to true. After shape is equal to data copy dot shape. Okay. Data shape after shape. Then drop percent after shape slash before shape. Okay. So it will show the percentage. Duplicate rows contain no false, duplicate count 0, and data shape. Okay. Applying above operation on original data. So we will apply all this operation on our original data. Now identification and handling of redundant features. For handling duplicate features, we have created a custom function to identify duplication features with different name but similar values below. For handling duplicate features, we have created a custom function to identify duplication feature with different name but similar values below. Def duplicate columns, then data frame. Okay. List 1 equal to list 2 is equal to this one. Okay. We will create two blank list. Columns equal to data frame dot columns dot values for I in range 0 comma length of columns, for j in range of I plus 1 comma length of columns. If np dot where data frame column equal to data frame column j comma true comma false comma all equal to true, ls1 dot append column I, ls2 dot append column j. If length of list 1 and list 2 return none, else duplicate frame equal to pd dot data frame. Duplicate frame feature 1 is equal to list 1, duplicate frame feature 2 is equal to list 2, return duplicate frame. Before handling redundant columns, okay, print duplicate columns, data copy none. It turns out that there are no duplicate columns present in our data. Identification and handling of inconsistent data types. Identification and handling of inconsistent data types. Before changes respective data types per feature. Now type frame equal to pd dot data frame equal to data dot dtypes comma column equal to types. Type of underscore frame is equal to dot transpose. Okay, so it will give the type of the invoice. Date should be in date time. Customer id should be integer. So what we will do, we will convert it into date time performing operation data customer id np.int64. Okay, pd dot to date time data dot apply dt dot date transforming object type to date time after changes respective data types per feature is like this. Okay, looking at the final data set, when the final shape of data rows column format data dot shape data dot head, so this will come. Now we will do our eda part. Okay, so before moving further into analysis, we will create a new feature that will show the total amount spent by customer on that particular product. Okay, another thing is, while accumulating data by machine, the error was introduced in quantity feature having some negative value. We need to change this feature with absolute value. Okay, converting negative values to positive. Data quantity np dot absolute data quantity, creating a new feature total spend equal to data quantity into data price. Okay, what is, now we will do our eda part. The question one, what is the ordered quantity of product item per day by the customer? So here what we are asking, now we will ask some questions. Okay, what is the ordered quantity of product items per day by the customer? So dx equal to data dot group by invoice date. Okay, we are doing group by invoice days as index equal to false dot aggregate dot sum. Okay, so figure plt dot figure fixed size 15 comma simin sns dot line plot. We will use line plot for this. X equal to invoice date comma y equal to quantity comma data equal to dx, and we will give color. Okay, now we will define x label, y label, and title. So in this graph you can see that on axis we are giving invoice date, quantity ordered per day. Okay, so this is the on these particular day it is peak is high. Okay, this is the highest, then this all these are highest. Okay, we can see high quantity order around the month of September, October 2018. Now we will ask second question, that what is the total sales of product items per day by customer. Hmm, plt dot figure sn dot line plot x equal to invoice date y equal to total spend data equal to dx, and then we will give color. Okay, so total sales per day invoice date, so you can see sales around the month of January 2019 was pretty high. December 2012 was pretty high. Okay, January 2019 December. What are the top 10 products that were sold at high quantity to the customer? What are top 10 products that were sold at high quantity to the customer? And data dot group by description as index equal to false dot aggregate, we will apply again for some dot sort values by quantity ascending equal to false, so we will quantify in descending. and top equal to dx 0 to 10. Now again plt dot figure itna sns dot bar plot x equal to quantity, y equal to description, data equal to top, quantity, description, plt dot title, grid, and all these. Okay, so paper craft, little bridge. So this is the highest sold. Middle ceramic, top stone jar, this is second highest, and then World War II gliders, asset design. So these are the products, top 10 products um, that were sold at high quantity to the customer. Paper craft, little birdie was has been sold at highest amount of quantity than any other product item. Okay, which are the top 10 product items that were sold at low quantity to the customer? Data dot group by description as index false dot aggregate sum dot sort values by quantity ascending is equal to true. Now we will keep ascending equal to true. Psns dot bar plot, x will keep quantity and y will keep description. Okay, so now we should change this name, but no issue, we can keep it bottom also. So items displayed above have been sold at only unit quantity. So these are the items which are sold very less. Okay, so these are the actually insights in the data we can get. Okay, what is the total amount that was spent per country? There are total 41 countries. Plotting all these in one go is complex. Instead, we will divide the plot. Okay, so there are 41 countries, so it will be difficult for us. Below X plot is different for both the plots. Okay, figure ax1 comma ax2 plt dot subplot fixed size itna sns dot bar plot total is spent. Okay, country data equal to 0 to 20, and then what we are doing sns dot bar plot total is spent, country data 22 1, 22 last. Okay, United Kingdom spent highest than any other country on buying items, while Nigeria spent lowest than any other country. These are few questions from here. If you would like to explore further, you are most welcome. Okay, you can do further. Customer segmentation techniques. In this section, we will explore two techniques of customer segmentation, that is K-means and RFM. The full form of RFM is uh, recency, frequency, and monetary. Okay, segmentation. First of all, we will see segmentation using K-means. We will be segmenting customer based on their behavior, that is quantity ordered and total amount on that product. Firstly, we will run K-means at default setting. Then we will tune it over multiple K values. Find optimal K. So segmentation using K-means. But before that, we will normalize that are important for clustering. That is quantity and total spent. So our quantity and total spent, we will normalize these two features. So log quantity and log total spent. Maximum iteration equal to 500, random state equal to 42. Okay, random state is the seed for randomness. Okay, now k means dot fit. K means dot fit data log quantity comma log total spend. Okay, within sum of square variation inertia. K means dot inertia. Okay, within sum of square variation inertia. Now we will do hyperparameter tuning, finding optimal K. We will iterate our model over some iterations, finding optimum K value for our clustering. Okay, we will check inertia defined as the mean square distance between each instance and its closest centroid locally as per the definition. Lower the inertia, better the model. Okay, we will use elbow rule in order to find the optimal number of clusters. Okay, so this iteration will take some time. Inertia value is equal to itna k values equal to x for x in range 1 to 16, x for x and for I in k values, k model equal to k means n clusters equal to I, maximum iteration equal to 500, random state equal to 42, k model dot fit data equal to log quantity log total spend. Inertia values dot append k model inertia. Print iteration comma I comma completed. Visualizing the inertia versus k values. Figure go dot figure dot add underscore trace go dot scatter x equal to k values, y equal to inertia values, mode equal to lines dot markers, fig dot update layout, x axis equal to dict, and then this tick model equal to linear tick 0 1 and d tick equal to 1. Title text equal to within cluster sum of square distances versus k values. Title x equal to 0.5, x axis equal to underscore title equal to k values, y axis dot title cluster sum of square distances figure dot show. So I due to network issue it is not showing here, but it will show. Okay, while now after this when we are performing this doing this, then we can see, as we can see that cluster sum of square distances values are pretty high. We can see that after k equal to 5 there is significant drop in inertia, so k equal to 5 is octave for our solution. Now our final model will be k means equal to k means n number of clusters 5, maximum iteration 500, random state equal to 40. K means dot fit x equal to data log quantity dot log total spend. Data labels equal to k means dot labels. Center equal to k means dot cluster centers. Visualization of clusters 0 1 2 3 4. So these are the 4 clusters. So for the visualization of cluster we will plot this figure comma x1 plt dot subplot 1 comma 1 ax1 dot scatter x equal to data log quantity, y equal to data log total spend, y equal to centers marker idna. For I comma c in enumerate centers ax1 comma scatter x equal to cx, y equal to c1, x equal to c0, y equal to c1, marker equal to idna, alpha is equal to this much, and h color equal to k. Feature space 1 log quantity, feature space 2 log total spend, visualization of cluster data, plt.show. So by this we can see our visualization. What are our observations? We can see clusters and their respective centroids are very dense. To understand better, we will look at the count of each cluster level. Figure equal to plt dot figure float equal to these are the colors 1 2 3 4 5 x ax equal to sns dot count plot. We will do count plot sns dot count plot x equal to labels data equal to data plot equal to sns dot color dot platy floaty total equal to data dot shape. For p in ax dot patches percentage equal to single quote 0.2 f percent dot format 100 into p dot get highest divided by total x equal to p dot get x plus p dot get width divided by 3 y equal to p dot get y plus p dot get height. Ax dot annote percentage comma x comma y. We can see that cluster 1 and 4 are more profitable because they seem to order more quantity as well as have high purchase values. On the other hand, cluster 3 has higher quantity ordered than cluster 0 but purchase value is lesser. Having identified the characteristics of each cluster, we can roll out targeted advertising, promotion offers, etc. Segmentation using RFM. Now we will do segmentation using RFM. Okay, so this is our last part. We will do this RFM also. Just wait a second. So R stands for recency, F for frequency, and M for monetary. Okay, what is recency? Days since last purchase. Okay, if score value is high, it is signifies that customer recently visited the shop. Okay, now frequency, total number of purchases. If score is high, it signifies that customer buying frequency is high. Monetary, total money customer spend. If score value is high, it signifies that customer spend habit is high. Okay, it is very old technique to segment the customers and it works very well. First we will calculate the RFM matrix for each customer. Okay, so customer ABC, recency frequency monetary 53 days 3 transaction 230 rupees. Okay, then 120 days 10 transaction 900 rupees. Secondly, we will add segment numbers to RFM table. 2 2 2. Okay, 1 1 2 3 3 and 3. Like this we will do. Finally, sort according to the RFM score from the best customers. So best customer is 444, brought most recently and most often and spend the most. No price incentives, new products and loyalty programs. Now loyal customer buy more most frequently. Use R and F to further segment. Big spenders spend the most. Market your most expensive products. Almost lost. Haven't purchased for some time but purchase frequently and spend the most. Aggressive price incentives. Lost customers. Haven't purchased for some time but purchased frequently and spend the most. Now lost cheap customers. Last purchase long ago, purchased few and spend little. Don't spend too much trying to reacquire. Okay, so this is the scenario. Now what I'm doing, I'm defining last date. Okay, date invalid dot max, so it will give the last date. Now date time comma date time and current date. RMF table data dot group by, then by customer ID as index equal to false dot aggregate invoice date equal to lambda x now x dot max dot days comma invoice lambda x length of x. Okay, and total is spent lambda x x dot sum. RFM table dot rename columns invoice date recency invoice frequency total is spent monetary in place equal to true. RMF table dot head RMF table dot head. So this is the scenario. Next we will segment the data according to the percentile, that is it 25 percentile, 50 percentile or 75 percentile. Quantiles RMF table dot quantiles q equal to 0.25, 0.50, 0.75. Quantiles equal to quantiles dot to dict and then quantiles. Okay, like this. So then we can find out these customer ID point itna, point 0.5 itna and 0.75 itna. Recency 0.5 this much, 0.25 this much, 0.5 this much and 0.75 this much. Frequency. Below we have created two functions that will help in achieving RFM and values. So here also we have created functions to achieving RF and N values. Okay, so now define calculate recency x y z. If x is less than equal to z by 0.25 return 4. L if x less than z by 0.50 return 3. L if x is less than z by 0.75 return 2. Else return 1. Now define cal frequency monetary xyz. If x is less than equal to z by 0.25 return 1. If x is less than itna, then like this. Okay, so recency frequency and monetary. So this is R value, F value and M value. What apply? Calculate recency arcs, recency comma quantiles, frequency comma quantiles and monetary comma quantiles. So this will come. Now we will append RFM score to a single figure. RFM table is equal to RFM table R value dot map string dot RFM table F value dot map string RFM table dot M value dot map string RFM table dot head. So this will come. Finally we can see important customers. RFM table RFM score equal to 444 dot head. So these are the important customers. We can match respective customers with their tables, with these tables to identify important customers. So here we have seen this case study. What is the conclusion? We studied in depth the data, its characteristics and distribution. We explored various questions related to customer behavior and their residency and buying habits. We adopted two techniques to solve this business problem using k-means and recency frequency monitoring. Both are used widely, but RFM is much better than automating the whole solution because we are more precise in identifying the customer frequent buying habits that and their spend. Whole solution because we are more precise in identifying the customer frequent habit buying habit and their spend. So thank you guys for this. So I will provide more content for machine learning and data science and expert data analysis in future. Thank you.